if you want, you can try doing animations just using regular forward kinematics, just with the bones, and it should be fairly easy to animate the character this way, and you're pretty much guaranteed your exports are going to work properly. So what I would do is I would save a copy of this version of your character right now, and then save a new copy and just rename it, where you're going to start adding controls for a more advanced rig. We're going to try to set it up so that it'll be good for animating close-up stuff, more detailed expressions, morph targets, and so on and so forth, but it'll also work inside a game. So I'm going to hit Alt-X and zoom up on the character's right leg. I'm going to go to bone mode and pick the foot. After you pick the foot, I'm going to go to Animation, IK Solvers, HI Solver. I'm probably only going to use inverse kinematics on the legs and feet, but if you want, you can create that kind of setup on the arms as long as there's a bend in the arms. I wouldn't do it myself though, so I'm not going to do it in this tutorial because I prefer to animate the arms with more precise control with the forward kinematics rather than inverse kinematics. So if you grab this endpoint here and move it around, you can see that now you can control the foot just by grabbing it and moving it. We're going to add a shape later to help us with that. Alright, and if you want, you can reduce the size of the goal. I'm just going to say 5. And for the purpose of knowing what this IK goal is, let's just change the name of it. IK right heel. And we'll make another IK goal, another HI solver. Select the toe right here first, the ball of the foot, and create another one, and we'll connect it to the right foot. So this one we'll call IK right ball of foot. Now grab the toe tip, and that would be the nub of the right toe. Create another HI solver and just click on the right toe. And just call this IK right toe. Let's go over to here to helpers and just grab a point. Size about maybe 5. And we'll uncheck cross and just check box, and I'm going to use the align tool, and I'm going to align it with the right foot, not the goal but the right foot itself, and I'm going to align the orientation as well. Okay, actually we don't want this one aligned here, we want it aligned here. We'll align this to right toe, and want the orientation aligned. If you go left view, you can see that it's pretty much straight horizontal. Okay, so we've aligned it with the toe. I'm going to shift drag to make a copy, and I'll make 2 copies, and I'll align each one. Align this one with the foot. Oh yeah, I want to align it with this. I don't want to align the orientation though. Apply, and I'll grab this one, and I'm just going to freeze the geometry here so that I can select it. So I'm going to freeze this selection. Okay, so I'm going to grab this, and I'm going to align that with the toe, and just the position, pivot to pivot. And we'll make another copy and change the size of this one. I'll say 7. I'm going to align it with the right toe. And let's give these some names. So we could call this one HLP for helper and right heel. HLP right toe. HLP right heel lift. And the bigger one, HLP toe lift, right toe lift. Let's grab this helper for the right heel. This is where you want the heel to tip upwards when it's in contact with the ground. So with move selected, oh, make sure you're not in local mode, go to view mode to get it down to here. And well, just place it where you want the foot to roll. And do the same thing with the right toe helper. So you want that center part to be where the toe is actually going to roll as it hits the ground. I'm just going to make sure that these two agree with each other. This one's at 1.319. Change this one to 1.319, and now they're the same. So what we'd like to do is we'd like this thing here, the right heel lifter, to rotate this IK right ball of foot as well as this right heel. And when these rotate, what that's going to do is going to drive this foot to bend here going up and rotate this as well. So we can grab this IK goal and this one and link both of those to that so that it will control those. Yep, that seems to work. Okay, similarly, we'd also like this toe lifter to lift the toe. To do that, when it rotates, it should rotate this so that it lifts up. So basically, if you rotate the toe lift, it's going to rotate this, and then to solve that, it's going to match the orientation of the bone so that it will align with the new rotation of this, causing this to go rotate upwards, and this will always show at the end of this bone. So what we'll do is select and link, grab this, and select it to the big one, which is the toe lift. Let's just make sure that works. Now for a really neat trick, we'd like it so that when we rotate this one, it's going to drive both of these, which is in turn going to drive this whole foot up, as well as this front part of the toe. We'll grab both these guys and make them dependent on this one. So we'll link those to this one so that this one drives these two, which in turn is going to make all of this stuff move. Hypothetically, let's test it. It's working. Okay, what we notice though, if we twist the toe back and forth like this, is there seems to be a slight rotation that we don't really want in here. So we'll go into motion, let's grab on this IK here, and there's a parent space option here. Start joint or IK goal. Click IK goal, grab this again, and that looks better. Let's make it so that the heel can drive the toe. So we'll link this, just this one, and link it to the heel. So then the heel can drive the toe. You can also control the toe tapping from the heel here too. Let's make a controller for the foot that will sort of be the master controller for this foot. And we can do that by creating a shape, and I'm going to use a line. You know, I think I'm just going to use a rectangle and put snap over here. Let's enable in viewport, but not renderer, and drag it into place. We'll make it editable, go to vertex mode, and maybe grab these two vertices, turn off snap, let's move this in a little more. I guess we'll want room for the other one on the other side, so we don't want to go too far. Grab these two, just moving them so that it'll be easy to select them. And I don't know, do we want this to always be under the foot, or do we want... I don't think the character's foot's quite on 0, so we may have to move the root bone down to get the character on 0. But for now, the foot spline is on 0. Okay, well, let's unclick this. I want the foot itself to be on 0, so I'm going to grab this root pelvis. Now here's the problem, we already set up the IK goals. That's okay, we can work with it. We'll create a master controller later that'll bring all of this stuff down so that the feet are actually touching at 0. And I actually kind of like them floating underneath, so I'm going to turn off this. With the editable spline selected, let us make sure we go to a reset X form, because we might have done some scaling or something here. Kind of want to collapse the matrix dependencies all into one single matrix, so reset selected, and then we can go collapse and collapse selected. Modifier stack result. We can rename this CTRL controller right foot and click outside of that. One more finishing touch though. I want it so that when we rotate this, it's going to rotate at the heel. So let's make sure the pivot point on this matches the pivot point for this bone here. So go to hierarchy, effect pivot only, and then we'll click the align tool and align it to right foot. Not the orientation though, just the position. Okay, so now the pivot is right here. I can unclick effect pivot. Okay, so this is going to drive this one, which is going to drive these ones. We'll grab this and link it back to this. So basically selecting the parent, and then when we grab this, it should drive everything. Okay, so now that these are all linked, everything's connected, and it's safe to freeze transforms, let's click on this one, this one, this one, this one, this one. So alt right click, freeze transform. Yes. Okay, so if I move this, I should be able to alt right click and go transform to 0, and it should be back to normal. So now that this works and we're safe to move on, let's save it as a new file in case we mess something up, and do the same sort of procedure on the other side. And to do it on the other side, now I'm going to change the color of this to green to show which foot it is. Let's just grab this shape here and create a mirror copy, copy out an instance, and click OK. And make sure it's not linked to anything, so I'll select unlink. Change this one to like a bluish color. And once I get the point helpers on this side, I'll just align it the same way I did for the other one. Actually, what I could do is just copy this value into here. and make it positive. Just to make the animation a little bit easier, we'll create this optional attribute holder. And we can add custom attributes in here. You can add specific numbers and copy them over to the other side for animations. So you got symmetrical animation. We'll get into that later. It'll allow us to have precise numeric control over the animations of everything that's driving the foot and leg movements. So we go to animation and parameter editor, key, I believe is Alt1, and it's using the object's current modifier that we added, this attribute holder, to add into, and we're going to name this heel lift, and then we'll do a toe lift. You go 0 to 100, I'm just going to go 0 to 10, right align, here's an example, and a float, and click add. And now you can adjust this, and later on we'll just connect this to our heel lift right here. So next we'll add a toe lift. Same thing, and we want to be able to turn at the toe too. So we'll add a toe turn, and it's going to go left and right, so -10 to +10, add. And if you wanted to lift at the toe, like a tip toe lift, tippy toe, and we'll go 0 to 10, add. If you wanted to edit that, or edit any of the parameters, you can click this edit delete over here, and make changes, whatever changes in here. I'm just going to take this underscore out. Accept parameter changes, apply changes. Okay, and then we can exit that, I think. Okay, let's go another -10 to +10, and call it foot turn. And that turns at the back of the foot. And foot lift, which lifts at the back of the foot. And it may be that we actually want to be able to point the toe or point the whole foot down too. So we might want to go -10 to +10 or -5 or something to positive. Okay, so foot lift should be able to go down also. So let's go edit and foot lift. Make it so it can go -10, accept, apply, and a toe lift, which should be up and down here. That should be able to go downward a bit too. So we'll say -10, accept, apply. Okay, now would be a good time to save it. And we're going to end up using the reaction manager to map all this stuff to controlling the appropriate helpers. So this point helper here lifts the heel, that's the heel lift, which is the first in our list. With snap toggled, see how far we want to be able to go up at the most. Maybe 70 degrees? That's very extreme. But yeah, we could go up to 70, maybe even more. Let's say 70. So I would write down that number, because what we're going to do is we're going to get that attribute in this controller here and get it so that it controls how far this can rotate. Click on here, that's that heel lift. In order to make this drive this through this custom attribute over here, we'll go into the animation menu and we'll use a reaction manager to control it. In the reaction manager, we're going to add a master, and the master is the controller, which has those attributes, those driving attributes. So we'll click it, and then we got to pick which attribute. So we'll go to the attribute holder, custom attributes, and we want to make a controller for heel lift to control this. So now, before you do anything else, make sure you click on this master here so that it's highlighted in blue, otherwise this isn't going to work. And before we do anything, we need to select something that we want it to control, and we're going to pick this one here, the heel lift. So we'll click on add selected and transform the rotation. Don't use the frozen, but use the 0 Euler, and I believe it's the Z rotation. Oh yes, if you pick gimbal up here for a reference coordinate system, you can see it is the Z rotation. So I'm just going to leave it on gimbal so that we can know which axis we're working with for everything. And right away it creates a default state. So when the spinner is at 0, the angle is going to be 0. And what we can do is create a state so that when the spinner is at its maximum value, which will be 10, that number we wrote down was 70 for the angle that we want it to be able to rotate to, 70. Okay, so now if we click on this controller and we, that's strange. Are we working with the wrong axis here? Change this value to -70, and I'm just going to reopen this to make sure that worked right. Okay, yeah, it should have been -70, and it seems to work. Okay, so the next one we have in our custom attributes list is toe lift, and it would be this guy here, the toe lift helper, which should control this. So we'll say a maximum of 55 up, 45 down maybe, 60 up maybe. So we'll write those down. So -60 and +45, I do believe. And you can see this is on the Z-axis because I got it on gimbal, so you can tell. Okay, so first of all, we'd add a master and then pick it and go modified attribute attribute holder, custom attributes, and we're working with the toe lift. So toe lift is going to be the master controller, and then we have to pick what we want it to affect. But first, let's make sure it's highlighted. Pick what we want it to affect, and then go add selected, transform, rotation, 0 Euler, the Z rotation. Default will be 0, which is fine. And we'll create 2 additional states, one for up, one for down. So this one will be -10, and -10, I guess we'll make it go up. So we'll say -60 degrees. This one will be +10, and it'll go down, say 50 as a max. We'll just click on it and try it out, make sure we didn't mess anything up. So +10 goes up. So I got these backwards. That's easy enough to fix. So I'll just go into here, change this one to 50, and this one to -60, so that when I pull this up, oh wait, maybe I didn't have it backwards. Yeah, I want it so that when I pull it up, the toe goes up, not down. So I'll say +10 for this one, and -10 for this one. That's right. Let's just hit 0. Okay, and the next one in the list is toe turn. So I'm going to click Add Master, and again, attribute holder, custom attributes, toe turn. And this is the toe controller. Okay, with that selected and this selected, I'll say add selected, transform rotation, and oh, I got this set to view gimbal, so that's a Y rotation. Add selected, transform rotation, and Y rotation. And it can go in 2 different directions. So I'm going to say -10, and let's just grab it first and see how far we want to rotate. We've already selected the attribute holder to be the thing that controls this rotation, and consequently we can't just rotate it. We could delete this controller and probably rotate it now. Yep. Almost might be even better to have this point helper a little further in, but should be okay. Okay, so I would say 45, maybe 55. 55 is really extreme. Yeah, I'd say 45 in each direction. 55 is getting a little bit too much. Let's double click all this. Transform to 0. Just making sure these are all zeroed out. Gimbal set. Let's go back and open up the reaction manager. We got toe turn here, and we got our 2 states here. So go -45, 10, +45. Maybe we'll go -50 actually. +50, just so we have the freedom to do it if we really want to. Oops, I'm on the wrong one here. Let's grab this one. Okay, there we go. Let's make sure that works. Good. If you have an old version of 3D Studio, you might need to exit and reopen Reaction Manager. If you see the numbers go crazy here, it'll still work right. It'll just be showing the wrong numbers in this value area. Next is tippy toe. Add a master. Click on the controller again, and we want to make a controller for tippy toe, and then we want to select this one. That's going to be on the Z-axis. So with it selected here and here, we'll go add selected, transform rotation, 0 Euler, rotation Z. We'll create a state, and say for 10, the angle will be, let's say 65. 65, enter. Okay, so I gotta go in the wrong way. It's gotta go negative. Let's say -70. So slide it up and down. Okay, that works. And then we got for turn, which is for turning at the heel back here. We could test that out. Maybe 75 at the most. That way. It's going to go down here, add reaction, or add master for this. Attribute holder, custom, and foot turn. Make sure this is selected, not selected, and go add selected, transform rotation. Is it a Y rotation? This one's a Z rotation. Okay, I guess this one will be the Z rotation. Transform rotation, Z rotation, I guess. Okay, so for -10, let's go -70, 10, 70. Make sure that works the way you expect it to. Okay, so apparently it was lying to me. It's given us a lift instead of a turn, so it is not the Z-axis, it is the Y. I don't know why it's showing the wrong one here. Anyway, let's zero this out. We'll go here. Whoops, we'll go here and delete this selected here. We can delete these states. So grabbing this, want to transform the Y rotation. Add 2 states, -10, +10, -70, +70, and test it out. Okay, that works. Foot lift. Okay, let's just grab this, rotate it in this axis. We want to be able to go maybe 65, maybe 60, going up. I would say 35 at the most. It's a fairly fat leg, it's colliding with itself. Now we're going to add a master controller. Modified attribute, custom, foot lift. And we'll grab this heel again, add selected, transform rotation, 0 Euler, Z rotation. It's not giving me the correct axis here for some reason. And create 2 states here, -10, plus 10, and minus 10, I think, minus 35, plus, I think it was positive 60. Let's just make sure that works okay. We got those backwards. We'll make this for plus 10 and make this one for minus 10. Drag up and down on this though, you should be able to, oh, got the numbers backwards here again. So this one should be 60, minus 60 I should say. Or no wait, it should be 60 down, right? This one should be minus 35. What's going on here? Okay, so it should be for minus 10, plus 35 degrees, positive 10, minus 60 degrees. Let's make that one 0 and close the reaction manager. You may notice that when you turn the leg, or when you turn the foot, or you do a toe turn, the knee is always facing this way. So the knee is not turning with it, and it would make more sense if the knee did turn with it by default. And there is a way to control that. If you select the IK goal thing here, the IKR heel, and you go to motion, in motion you'll see this IK solver properties submenu here, and you could pick a target and have something out here that you could have it point to and control that, or you could have it so that its parent space is the start joint, and so it's by default going to be lined up with the thigh because that's the start joint for it. This is the IK goal joint right here, down here. We want the angle for the IK control to affect everything based on the angle of the foot. So parent space will pick IK goal. So then that way, if we change this swivel angle manually now, you can do that. So that way, if you change the angle of the foot, for example, if I make the foot face this way, you can see that the knee follows along. If, for example, you have the leg facing this way, but you want the knee to swivel a different way, you can again go into the IK goal, go to motion, and then again in the same menu here, you can go swivel angle and you can change it. That's kind of a pain. So we're gonna wire up a parameter to control the swivel angle. We'll actually use the reaction manager for that too. Let's go back to our foot controller, and I'm just gonna transform this to 0. And let's add another custom attribute called the knee swivel, which will control that swivel we looked at in the motion panel for the IK goal. We'll create another parameter under animation, parameter editor, and we already have attribute holder selected over here, so it'll be the selected object's current modifier. Let's name it knee swivel, and I'm going to go 0 to, actually I'm going to go negative 10 to 10. Alright, and let's click add. Oh, I have this one set to center, so let's click on edit, knee swivel, right align. Okay, and now these are all lined up, so let's go reaction manager, add master, click on this, our modified object, attribute holder, custom, knee swivel. Now we've got to pick the IK goal, or this isn't going to work. So once you've picked it, we need to modify the swivel value for it. So we'll go up to add selected for what we're controlling, IK goal, no, swivel angle right here. And there should be two other states, one for negative 10, which I'll just make as negative 80 or 90 maybe, and 10, positive 90. I'll just test that out. Okay, that works. Let's create another 5 centimeter point helper, line it with here. Basically just do the exact same thing that we did on this side and duplicate that whole process on this side. So you may need to rewatch this part of the video to see how to do that and then just duplicate it. And you should be able to get this one to work the same way. One thing you can do is create a point helper just to make it sure it's exactly lined up. You can line up the positions and orientations with the point helper on this side and then realign it so that its X coordinate is lined up with this one. So just uncheck these ones, and then that way when you go to left view you can see these things overlap perfectly, which is what you want, because you essentially want to mirror from one side to the other, sort of, except you can't just use mirror to do it. So, and don't forget, when you create your HI solvers, you want to start with your IK goal here first. After you've hooked up your IK, it's your IK goals that are going to drive the leg, not the bones themselves. So if you needed to move them around to test them, you want to grab those. Also, don't forget to grab the two IK goals here and here and connect them to this little one here, so that that inner heel lifter will actually control both of these. So select and link. Oh yeah, it did work. Okay, let's make sure we fix the parent space to this as IK goal. What's going on here? Well, that doesn't work. You may notice when you're working on the mirrored leg that if you click on the IK goal for IK left ball of foot, you'll notice when you switch from start joint to IK goal, it's going to flip it upside down unless you put 180 for the swivel angle. I've heard there's a couple other ways to fix that too. Just a note, if you're switching between different controllers and you want to see the reactions for each one separately, you can click on one, click show selected, and it'll only show the reactions for that particular controller, and you can do that for each time you switch back and forth. For toe lift, I actually went back and changed this so that 60 degrees up for the toe and 50 degrees down, because it made more sense. I guess if you're not sure what direction you set it for, you can always give it a strong value like 90 instead of 60 and test it and see if it is indeed going the direction you expect. And then change it back to the value you want. Again, don't forget about the IK goal from here to here on the leg. Instead of using start joint as the alignment, use the IK goal. And that way the angle of the knee will follow as the foot turns. If it's acting strange, you may need to change the swivel angle to 180 degrees since it is mirrored and it might act strange. In my case, it worked fine. Okay, so I just went ahead and just did a quick test where I used auto key and created a pose like here, kind of in the middle somewhere, and then back like the foot is going back to run. Click on here and go Alt X, you can see through the character. What I did was I created expose transform, ExposeTM, and I made it into a box. I aligned it to the thigh, the left thigh here. I temporarily parented it to the pelvis. Eventually I'm going to unlink it from the pelvis and I'm going to parent it to a main control object that controls the position of the character. And the reason for that is I don't want any non-bones in the linkage of the bones when I export it. It probably actually doesn't even matter, but I'd rather have this parented to a main controller. And actually it doesn't even matter where the expose transform is, because like it could be anywhere. It could be off in the corner here even. I like to put it where I'm trying to do the exposure so that I know what it's associated with. It'd probably be a good idea to give this expose transform here a name so I know what it's for. Let's freeze the geometry here. So then I can pick this, change the name to expose transform, and I'm just going to change the 001 to left thigh. So the reason I wanted that, I want to know the matrix, or the rotation transformation of this thigh. And with the IK set up here, that's kind of driving all this. Because of that, when I want to wire parameters, I don't have direct access to what this actually is. So to get access to it, I attach this expose transform, which I parented here actually, and then I select a node. And so in here in parameters, you can select an expose node. I click on expose node and select the left thigh. So now it's exposing information about the local rotation angles. I don't really care about the world angles or the positions. I just want to know the local Euler angles. By default, the Z rotation, so the local Z rotation is, rotating this way, which is what we're interested in, because we want to figure out how much rotation to affect this part right here, because we want this to kind of drive the rotation of this a little bit. We're also going to add a control so that we can add or subtract extra rotation to this if we want to in the animation. With this wired to this, you can't just grab this bone and rotate it. So we'll have to add an extra parameter controller or another object that we can move around, and it'll figure out the look at angle for that object and add in the difference to the rotation that this is going to be set to by the wire parameter that's driving this. So that's getting into a much more complicated rig setup. So I'm probably going to try to keep this as simple as possible. We might just use a parameter down here where you can adjust the angle of this. So what we do is we click the expose node, and we want the information about this angle to drive the rotation here. So I go right click, and even though it's blacked out, you can actually select wire parameters down here, transform, or no wait, we want object expose transform helper, and we want local Euler Z. And when you click on that, you can click on this and you can go rotation, 0 Euler, XYZ, and the Z rotation. So then you should see it here and here. Another way you can get to that dialog if you've closed it is you can go Animation, Wire Parameters, and you can open up the Wire Parameter dialog with Alt-5 or just click here. And then what you do for the left side, you click what you want to control it. So we want this thing to control this thing. And then you click this little refresh button here. Then you click the one for the right side, which is what is being controlled, the slave, and you refresh over here. And so if you go down this list here, you can see this one is kind of in bold. So this one is controlling this one here. And you can see when you click the red here, you can see it show up in green on this side. Then you have to click which way it's connecting. So this one is going to drive this one. So you can actually change what connects what. There's also a two-way that's possible. We want the left to drive the right. So then you can use this update button or the connect button. It'll say connect it first because they won't be connected. And then the parameter that shows on this side will disappear, and then you'll get this local Euler Z on this side. And so what I did was, if you go into the expose transform, you look in the local Euler angles, you can see that it starts off with negative 13.174 degrees. However, we need it in radians here. So I go degrees to radians, and I want to subtract that amount from the negative amount of the local Euler Z. And you find that out from just playing around with, like if you start off, just go negative or positive local Euler Z, rotate it and see what it does, then make modifications and hit update and just keep doing that. If you didn't want to use degrees to radians, you could, for example, use a calculator, or you could use an online converter and just go 3.14. If you want more precision, 15926,536 divided by 180, because that's 180 degrees. So pi is 180 degrees. Divided up into units, 180 units. And so a single unit is this size. So then you times that by 13 units, 13.174. The radians of Z rotation 13.174 is 0.2299 essentially. So you could put that here instead if you wanted. So if this needed to be positive and it's at negative 13.174, we'd say plus 13.174 to rotate it back the opposite way. Just ignore the divided by 2 for now. So this would get you, this plus degrees to radians 13.174 would get you to where it should be if it was, it's to kind of get that Z as a 0, because it's already rotated 13 degrees. We don't want to rotate this an extra 13 degrees, so we're trying to get rid of that. That's why we add it back in. But since we're multiplying this all by -1, this becomes negative, this becomes negative, because we want to rotate the other way. And we say divided by 2, because I want it to only rotate half the amount that the thigh is rotating. So it may seem confusing, but if you just do it one step at a time, where you just start off with this angle, play with that, figure out what kind of offset difference you need, how much you want to divide it by, or times it by, and just keep updating and trying it and see how it looks. So now, when I go through those frames, you can see that that rotates at half the amount that the thigh does, which looks pretty good. If we want to add additional control to this, what we could do is add in an extra parameter angle. What we could do is we could have an object that moves out here, and we could use a look at angle to figure out how much extra angle should be added, and it would be parented to something over here. I would create an alternative version of the character for where you do need to make different kinds of adjustments, where that 50% isn't going to work, and that would only be for specific animations. So the 50% actually makes things really convenient, so you don't have to worry about controlling this at all. There may be certain situations where parts of the character are moving around and you need to make specific adjustments. So to do that, I'll just show you real quick. We could create a shape. I'm going to go with a circle here. I'm just going to shift rotate this 90 degrees, and then we'll grab the shape here, left view, and drag it back. And I'm going to shift rotate this way too. That way, no matter what view you're in, you can see this little shape thing here. So we can copy this and use it and just temporarily hide it, and we can use it for creating other shapes for moving stuff around. First of all, let's grab all this, convert to editable spline, hit Z here, and then click on spline mode, and I'm going to use attach to combine these spline pieces, so now they're all one. And you don't have to use a spline to create a controller. I just like to use shapes that I can just pick all my controllers by going to selection mode shapes, And then if I only want to control the controllers, I can just use the shapes mode. Also, if I'm using shapes for my controllers, I can go into this rendering here and I can say enable in viewport. So it's really easy to grab the controller because it's got some thickness to it. I'm going to reduce the number of sides, maybe 6, that looks pretty good. Doesn't have to look good, you could even go down to 3 or 4, yeah, even 3 technically. I think I'll use 6 just because it looks good. I'm going to change the interpolation value. It's got 6 steps right now. I'll go 3 steps, that should be enough. And you can change the thickness value too, that's a bit on the thick side. So if it's ever in front of anything, it's going to obscure it a bit. Maybe 0.4. It's easy enough to grab. So I'll call this controller template. So I'll just move this off to the side. What I would recommend doing right now is to use the reset X form, and that way if you did any scaling or anything on it, it's not going to translate through any kind of hierarchy. So after you've done that, you hit collapse, and we can collapse selected to modify our stack result. And what that does is it will change it back to an editable spline where all the matrices that this is dependent on are kind of combined into a single matrix. So you kind of gets rid of those dependencies that can mess things up later, potentially. I'll just leave this off to the side and I'll drag one out, and I'm going to change the name of it, and I'll call it CTRL-R. And I'm going to get rid of this and maybe add it later, or maybe I'll just hide it and disconnect it temporarily. But I'm going to add it in here for now, just to show how this sort of thing is done. So I'll move this template one way over here or something, and then hide it. Hide selection, not unselected. So first I'm going to use the align tool, and I'm going to align it to this one, because I've got the geometry frozen, so I can align it to here. And align the rotation as well as the position. This may not be perfectly straight back. Ideally, I'd like to move it along the direction of this bone, but I'm just going to drag it back to here and kind of eyeball it. I could even align it vertically to this. Yeah, same Y position. X position will be different. Okay, so what we want is we want this to be look at constrained to this. Like I said, this is just an example, so this will be temporary. So I'll grab this bone, animation, constraints, and I'm going to use look at constraint, and constrain to this. Now, if anything weird happens and it gets all gibbled, pretty much as a rule, what I would do, first of all, let's pick. So I'm picking rotation parameter here, and look at constraint, you can see right here what it's looking at. As a rule, I would always click on keep initial offset so that this doesn't get rotated around in a circle or anything weird. If we want to, we can also change the length of this line that shows what it's looking at. So I'm going to drop this down. I guess actually you could keep it long enough that you can kind of see what it's attached to. So just testing this out now. Now we have this sort of control. Actually might have wanted this thing to be closer, so I'll just do this. And so now you got a lot of extra control of this cheek during animation. So if the leg's doing anything weird or that 20% thing doesn't work, you can switch to using this look at constraint instead of the 20% connection. So what I would do is I just have 2 copies of this file. Ideally, you'd want to figure out a way where you could just switch between the 2 in a single file. I'm not actually sure how to do that at the moment. But what I do is I just have 2 different copies where I have one version where I can use one type of character animation and one where I can do the other. With a character like this, I would say driving it with this 50% of whatever the expose transform says the thigh is doing would work fine. I can't really foresee needing that much extra control with this specific character for something like that. But now you know how to do this and the options there. If you would rather have absolute control all the time, then I would go with this approach. If you want a really easy, simple animations, then I would go with the other approach. So I'm just going to temporarily remove this look at constraint, and I'm going to copy the technique I used over here onto this side. And then I'm going to hide this. So let's click on look at constraint, and we can just, I guess we just delete the look at target. And then I'm just going to hide this one. Let's hide this. And I'll just quickly go ahead and do the same thing I did here to get this wired to go at 50% of the motion of the thigh. Let's just check that wire parameter dialog, and I'll open this up, and I'll grab this guy, refresh on this side. Okay, so I only have it controlling the Z rotation. If you wanted to, you could add a small percentage of Y and X rotation from here to here. I wouldn't do it until the need comes, until the need arises. At the moment, based on the simple animations we're using, we don't really have a need to do that. If you're gonna hand this over though to an animator, what I would do is set up a bunch of animations on the timeline for different motions of the thigh and test out how those animations look and make some fine-tuning adjustments where X and Y rotations are also wired from the transform to whatever degree. Like if you wanted to go 0.1, so like 10% or 20%. Maybe those would work good at 50% also. I'm not sure. I haven't actually used this technique on this part of the body on a character before I was just manually animating the bones. Okay, so I just quickly set up some animation for this other foot here, and this other thigh. And I have this expose transform, which I probably should name. This one's named like this, so I'll just copy this naming. And I'll change this to R thigh. And what I'll do is this one here is set to expose the left thigh. I don't have this one set to expose anything right now. So let's pick a node, and that will be this one here. Okay, and we want, so it looks like it's the same here, 13.174. We want to zero that out and do the same thing that we did over here. So just to make it easy, I'm going to refresh this side here, grab this one, refresh this side, and then pick these two. Okay, and then I'm just going to copy this entirely. Then I'm going to refresh this one, grab this one, and refresh on the right side. So local Euler Z is what we're trying to correct. So it's going to be minus local Euler Z, minus degrees to radians, the 13.174 we want to zero out. This would be the same as local Euler Z plus degrees to radians, 13.174, except there'd be a -1 in front of the brackets for this because this all has to be negative. So it's like timesing -1 by both of these, which makes this into a subtraction right here. And then divide it by 2 because we only want it to be 50%, or half the amount. You could times it by 0.5, it'd be the same thing. So let's update that and test out that animation. And it's not working. Okay, why is that? Okay, so when I move this, the exposed, yeah, you can see right here, the exposed value is changing as the thigh moves. So did I pick the wrong parameter to control here? Local Euler angles, Z angle. I forgot. In our rotation list for this bone here, we have a look at constraint here that's still active. So let's just delete that completely, and we'll only have that on the other version of the character rig. So now this exposed node is going to be wired to drive this cheekbone here. Go into here, do the same thing we did on the other side, and the rotation's in the opposite direction, so let's multiply this by -1 here. So this becomes a positive, this becomes a plus, and update there. That's because they're mirrored bones, so they don't necessarily rotate the same direction. There are ways of flipping the bones around by selecting all of them in the chain and then going effect pivot only and rotating them. I'm not going to do that though. I don't think it's going to be necessary, so just thought I'd let you know that that is possible. And then they would rotate exactly the same way. Okay, so testing it, they seem to be okay with that wiring parameter setup. And then we don't have to mess around with those bones at all. There's a few different ways we could do the tail animation. One would be to go to Animation, IK, HI Solver, and connect from the nub tail, so something like this. HI Solver, and click the tail one. Then if you click this little crosshair and move it around, you can control the tail that way. And under most circumstances, that would work fine. You could add an extra strainter controller to get a little more control out of each portion of the tail. I've never done that before, so I'm not sure how to do it. I'm not going to make a tutorial on it. So I'm just going to hit Control Z and back out of creating that. A couple other ways you could do this is you could create little ring controllers, maybe one here, and then a tip controller out here. And that way you can create an orientation constraint for each one so that its orientation would match to the ring controller. Orientation constraints can be found in here. You could even use a look at constraint for the tip, for example. Another simple way to do this, let's go unhide by name, shapes, controller template. It's going to grab this and shift right drag to make a copy. I'm going to call CTRL, tail. And for now, I'm just going to temporarily align it to this nub here, just by position, and pull it back a bit. Since it's in the middle, I'll give it a color of red. And what we could do is do an orientation constraint from here, or even from here to here, and make each one of these a sort of a fraction of this rotation by dividing it by a number. Or we could make this one the orientation constrained by doing this, constrain orientation, and make sure to click on keep initial offset. There we go. So then if I rotate this around at all, the tail does exactly what it's doing. And the weight is 50. Probably wire parameters are our best bet here. So I'm just going to go wire parameters, and we're interested in, I guess, the X, Y, and Z rotation of this. So first of all, let's test out the X rotation. So local axis, let's go gimbal here. So in this case, X is sort of the Y-axis. Alright, well that's weird. Wonder why these are so different. This one, X is up and down, so we want X wired to Y apparently, in the opposite direction. So disconnect there, disconnect there, and we'll go times 2. Oh, and this should be Y rotation. Or no, wait, no, that's right, that's right. Let's get rid of that orientation constraint from this bone here by hitting delete in here. So instead, I'm just going to wire parameters. The rotation of this is going to affect each one of these. It doesn't give as much control as if you used a 3 rings and individually have each one control the orientation of these bones, but it should give you enough control to make some pretty good animations. If you need more control, again, you could do like before, where you can add individual parts that will constrain the orientation of each bone individually. So I'm just going to wire these together so I can do some simple animations with the tail. Transform the 0 Euler XY and the Z rotation to match up with the Z rotation on this one. We want this one to drive this one. Okay, so I connected the wrong ones together. Just going to hit disconnect on this. Yep, X rotation. So the X rotation is going to control the Z rotation on that side. So I'll highlight those two. Left to control right, connect, and let's see if that's working. Yeah, X is controlling the Z rotation, which is what we want. Okay, so I'll just click Y and Y, right, and then connect, and Z and X, right, and connect. And make sure that I connected the right ones. Oops, I did not. So the Z-axis in here is actually going to be, from the looks of it, the Y-axis. So Z controls Y, and if that's the case, then the last one left is Y would control X. Let's just make sure that's right. I could even multiply them by 0.5 to make it a little less extreme, so I can still use my angle snap and still have a certain amount of precision with the tail motion. So I'm going to wire this one to drive this one 50%. So I'll refresh the master on this side, and then we'll refresh the slave on this side. And in this case, I think they should just match up. I think these are the same orientation. I'm not sure. Let's see, let's just check. That's Y. Apparently X is this way and Z is towards us. And same for this one. So Z, tail 1 and tail 2, connect. And I'm going to say this one's times 2. Oops, what did I do here? Let's check to see if this is working still. Okay, yeah, that's going twice the speed, so that's correct. Might even want to go 1.5, and then for this one we'll do times 2. So Y and Y, connect, times 1.5, update, X and X, connect, times 1.5, update. Grab this thing, move it around, see if it works right, and then I'm going to grab this one, refresh as a slave on this side. Grab this one, refresh, or I should say as a master on the left side, slave on the right side would be tail 3. I'm just going to match up X with X, and I'm going to say times 2. Oh wait, we'll make it 1.5 of whatever the previous one was, just like we did before. Make sure to pick a wearing direction. Times 1.5, Y and Y, Z and Z, and we'll test it out. Yeah, that looks pretty good. We don't got as much exact control of the tail. If you want it to flop around really nicely with the run animation, very specific control of how the tail moves. You may want individual controls here. If you really wanted to, you could create another version for very specific control for like a run cycle or something where everything's going to kind of flow around. Same thing with the hair. The hair we might actually try to avoid using a bunch of individual controls because it's going to look like a mess. I'd be more tempted to just go into X-ray mode and pick the individual bones I want to animate and match them up to whatever flex makes them do when you have the flex modifier active. I would save as a new file right now and then select everything except for the template controller over here and alt right click and use freeze transform on it. This one's not linked to anything right now. We're going to create a common controller here around the hips probably, and we'll link it to that, and we'll have to do another freeze transform for this object after we do that. Okay, let's go to create a shape. You can use whatever shape you like, really. I'm just going to go with a simple circle. Drag out a circle and enable in viewport. It's checked. Zoom in here, see how big this is. I'd like to be able to grab it a little more easily. Maybe I'll set this one to 0.6 centimeters. Actually 0.5 is good. I'll change interpolation to the sides. I'll just use 4. So grabbing this, I'm going to use the align tool and align it to the root pelvis. Since this is only going to be a restraining position, we don't really care about the angle alignment, so we'll just go with position. And we'll rename this one common controller or center of mass controller. I'll just call it center of mass. So that just kind of alters the position of the center of mass of the character. And then we'll have other things that are kind of grounded to it, so that when I move this around, it'll move the other controllers with it, as well as the skeleton of the character too. The feet will kind of stay put, but they will move around with a ground master controller that we'll add later. So I'm going to grab this and I'm just going to shift drag up as a copy, and I'm going to name this one hip controller or CTRL hip and hit enter. I'm going to drag down the radius and the parameters here, and we'll align it to this, and align the axis to, hit apply, okay, and oops, let's go to view. I'm just going to grab this controller and this one, use reset X form, and then collapse. Selected to modifier stack result. And this spline here, I'm going to go to spline selection mode. So not the object itself, but this selection here, so that when we rotate this, it's not going to change the pivot angle. You should see in the bottom, in this little box here, it'll say 90 once you get it to 90. And it's a lot easier to do that if you get your angle snap turned on. So for hip controller, or for this common controller, I'm going to change it to, I think, a gray or something to show that it's a master controller. It's a dark color. Okay, I'm going to shift, drag this up a bit, and I'm going to call this control spine 1. Let's grab it and align it to spine 1. Position and orientation. Let's see, this one should be aligned as well. Okay, so that was not lined up for some reason for orientation. So we'll rotate that one 90 degrees, get the sub-object level of this spline, and rotate it 90 degrees. And in a sub-object mode, we can play with the scaling on this, change the shape, or we can just scale it down. I don't want it too close to the body. So now the pivots should line up with those bones, which is what we want. And I'm just going to shift drag this up, and we'll make this one for the neck, and I'll select to align it. It wants to pick the geometry right now, so let's go to bone mode only, and it's lining up to the neck. And again, I'm going to go to the spline mode and select the entire spline and just kind of scale and reorient it so that it's going to be easy to grab. It's not going to obstruct the other controllers for the arm and stuff. You might even want to put the neck controller behind the head to make it really obvious that it's the neck controller, though. I'm just going to leave it around the head, I think, or around the neck. Scale it down. Yeah, it doesn't look like it's going to obstruct the other controllers, so I can probably leave it like approximately that size. Should be fine. We can grab this again. Let's make sure we're in select anything mode. I'm going to shift drag this up, make a controller for the head, and go to spline edit mode, select all. Just make this little crown up here to control the head. And keep in mind I had it in sub-spline mode. If you did any scaling or modifications, you want to make sure to go over into the tools here, reset X form, reset selected, collapse, and collapse selected to modifier stack result. So any scaling or anything isn't going to translate through the hierarchy in any undesirable way. If you do scaling though in one of these selection modes, it won't really matter, so you don't have to worry about that. I'm going to line this in with the head bone. Or actually, we could align it with the jaw, because that's sort of what's driving our head here. For now, let's make the head transparent. Maybe the eyes too, and the hair. We'll grab the head, the eye, the other eye, the hair. Freeze selections. That way we can't pick them by accident. And grab this one. Grab the spine and the pelvis root. With those both selected, we'll select and link them to the center of mass controller. And in that way, if we do anything with this controller, it'll affect the root and spine one of the character. And we're going to want the other controllers too, to tag along with whatever that controller is doing. So let's grab those. Don't forget the neck controller. And we'll link all those also to this center of mass controller. That way, if we move this around now, they follow too. So while we still can, while we haven't set up any wiring or animation, let's make sure we select all of these. And I'm just going to make sure that everything's where it should be. Okay, so we've got all these new controllers selected. Spine, hip, master, neck, and head. I'm going to Alt-right click and say Freeze Transform. So now, if I make any kind of modifications to any of these, if I Alt-right click and hit transform to 0, everything should reset appropriately. Of course, that is provided I have them all selected. This hip controller out here will control the hip, which will be useful for running and walk animations to make the hips, make it so that you can adjust the hips appropriately. So selecting the hip bone, select and link, and attach it to the hip controller, and then grabbing the spine bone, select and link and attach it to the spine controller. I'll just test these out to make sure that everything's working as expected so far. For spine 3, let's grab that and link it to the neck controller. If you open up your schematic view, you can kind of see the hierarchy of the bones and controllers and such. And it occurs to me that since we're exporting this as a game character model, the bones themselves, which are in purple here, we don't want them to have a controller as a parent. So, exiting schematic view, we don't actually want to link these bones to these controllers. Instead, we're going to use what's called an orientation constraint. So as you can see here in the schematic view, by linking spine 1 and root pelvis to center of mass, root pelvis is no longer the root bone, which is not what we want. So let's click on the root bone, unlink, click on the spine 1, unlink, and we'll click spine 1 and we'll link it back down to the root bone. So now anything I do to the root bone should affect everything else. Okay, so instead of linking the root pelvis to the center of mass controller, we're going to use a position constraint. And click on center of mass. Oops, we did that wrong. Okay, so we need to delete this from spine 1. Grab the wrong one here. We want the root to be position constrained to the center of mass. So now if I grab this, everything should follow. Then when I look at schematic view, spine should be a child of root pelvis. Root pelvis should have no parents. So we just want to use the controllers to manipulate things by a constraint, but we want the hierarchy to stay intact so that the root is actually the root. There's nothing above it. We can grab these two guys, the pelvis and spine 1, and do an orientation constraint on both of them with the hip controller. Let's do that one at a time just so that we don't make this confusing. First we'll grab the root, orientation constraint, the hip controller, click on the rotation, and you should see the hip controller here, and click on keep initial offset. Then we'll grab spine 1, constraints, orientation constraint, hip controller, and click on keep initial offset. So now if I change the orientation of this, controls the hip orientation and pelvis orientation. If I move this position around, it doesn't change anything. You could position restrain it if you want to. Actually, we don't want the hip controller to modify the spine 1 orientation. We'd actually rather do that with this controller for spine 1 here. So I'm just going to click on this and delete it, and instead I'm going to go to animation, constraint, orientation, and click on that control spine 1. I click on keep initial offset just to be safe. So if we go to the chest bone or spine 3, we can use an animation constraint and use the orientation constraint so that the neck orientation controller will control that bone. Remember to check off keep initial offset. So let's check out what's going on with the spine here. And as you can see, the middle spine bone doesn't really do anything. It kind of stays with its parent, spine 1. So what we'd like spine 2 to do is do partially what spine 3 and spine 1 are doing. And spine 3 is following this, and spine 1 is following the spine controller down here. So what we can do is grab the middle one and just give it 50-50 of those two. So we'll go animation, orientation constraint, and we'll pick spine 1 and make sure to check off keep initial offset so that it's aligned properly the way it should be. If you don't do that and you ever go to make clothing or skin corrections, you're going to end up with problems. So make sure to check and keep initial offset. Okay, so in your orientation constraint rollout in spine 2, click on add orientation target so you can add the other controller, the neck controller. So then after you click on control neck, and you should see that each one is weighted 50%. If you had more spinal parts, you could keep adding orientation targets. If you had 3, each one would be like 33.3 for the weight to kind of get 99.99 or whatever, 100%. We could have done the same with the tail too, like add some loops, one here, and one here, 3 circles, and control each one. Like say you had like 6 segments here of tail, you could control each one by certain percentages using add orientation target. You could also do some really sophisticated stuff too, where you could control the animation of those using like a warp modifier or something, a space warp, like something like a wave. So that works for tails and tentacles and things like that. But for that to work right, I think you'd have to use specific keyed morph targets and export those. There's probably a way to set it up so that you can get the controllers to wave. Might use scripts for that, but that would be a much more advanced rig. Let's test this out and make sure that we got a nice even distribution of the spine's motion. You could use wire parameters too for this sort of thing, or even an IK solver, or I guess technically you could even use a reaction manager, but orientation constraints work really well for this, so that's what I'm going with. So next we'll grab the head or skull bone, use an animation constraint, and constrain its orientation to circle 001 apparently. Keep initial offset needs to be clicked. We can grab this and change the name of it to CTRL head, and it updated the name of it in the orientation constraint rollout of skull. So now if we reorient this, the head should follow. As before, we're going to want the neck to kind of blend between the orientation of spine 3 and skull, following the neck controller and the head controller. So we'll use an orientation constraint between the neck controller and the head controller to do that. So grab the neck bone, animation constraint, orientation constraint, head controller, click on keep initial offset, add orientation target, and click on neck controller, keep initial offset checked. Everything should be okay. You can unclick add orientation target, and then we can grab either of these 2 controls and test out the neck and make sure it's bending and twisting the way it should. It might be easier to see this if we unfreeze everything and make everything visible. Okay, let's just test this out. Start with the neck controller, which is turning the top of the spine. Free selection. Just going to take a look at the bone orientations and make sure that I haven't. So at this point you could select everything, and I would save it first and alt right click and go freeze transform. I had to go back and open up a previous save of this because I actually linked the root pelvis and spine to some of these controllers, and they shouldn't be linked, they should be animation constrained. So as soon as you go to freeze your transforms, it's going to mess things up. So I position constrain the root pelvis to the center of mass controller out here, and I can orientation constrain the hip root bone to this hip controller here. So I'll go animation constraint, orientation hip controller. It's going to grab this and make it the same color as the bone so we know what it affects. And as far as spine 1 goes, I'll scrap that, animation constraint, orientation constraint, spine 1. I'll make sure too to grab this head controller, neck controller, this one and this one, and we could position constrain them center of mass, or if we want, we could actually link those, which should be okay. So anything I do with the center of mass, it'll affect all these other ones. That may not be the desirable result, so instead, hit Control Z, because perhaps we just want to be able to position the center of mass, but we don't want to change the orientation of all the bones to follow it. So we could grab this, the neck, spine 1, and hip, and just use a position constraint. If we do that though, we got to move everything back up into place. So I'm going to allow this to drive the orientation of these, so I'm just going to have these linked to this. If you use the position constraint and constrain the positions of each of those controllers to the center of mass controller, you can click on each one, like neck for example, click on keep initial offset under the position constraint rollout, and sort of do that for each one. So now when you change the position of the other ones follow, but the orientation is dependent. Or I should say the orientation is independent. So I can have this drive orientations independently of the position of the center of mass. Right now the neck controller doesn't control anything. We could even change this from neck controller to like controller upper spine, because technically that's what it is. It's the top part of the spine, or we could say top of the spine. And what we'll do is we'll grab that top bone, not the neck bone, but the chest bone, and use an orientation constraint so that its orientation is going to match the controller for top of the spine. And make sure to go to the rotation rollout for it and click on keep initial offset. And we already got spine 1, so we got the top one and the bottom one, but we don't got the middle one yet. So we'll click on the middle one, and we'll give it a 50-50 distribution, where it'll be half influenced by top of spine controller and half influenced by bottom spine controller, so it kind of blends between the two. So to do that, we'll go to the orientation constraint, and we'll select the bottom spine, click on and keep initial offset, click on add orientation target, so we can add in the second influencer, which is going to be top of spine. And you'll see the weight should be 50-50. If you're doing more segments in the spine or in the tail and you wanted to add more controller mechanisms along the way with different influences, you can have these weight values distributed differently depending on how much you want each controller to affect each bone within a set of segments, set of bone segments. So now if I turn the head or turn the top of the spine, it distributes about 50-50, and you can see it more when you move the spine 1 controller up and down like this. If we grab the hip controller, the hips just kind of follow like this. To actually bend the character forward or backward, you have to use the upper spine controller. It would almost make sense to make this into something that kind of wraps around the upper chest instead of just a circle around the neck. Have it so that it follows the position. So grabbing the head bone, we can add an animation orientation constraint to the head controller, and for the neck bone itself, let's make it 50-50 between top of spine controller and head controller so that it's blending between the two. So orientation constraint, again, head, keep initial offset, add orientation target, and add the neck or top of spine. So bend the head forward or backward, you should see the neck evenly distributed. Now I would save this and save it as a new file, and select everything except for non-used controllers, and if we did everything the way we should, then when I hit freeze transform, everything should be fine. Since it's not, we know something was wrong. So what I recommend doing is going through each of your bones that's affected by one of these controllers. Just make sure you got keep initial offset checked off on each one. Maybe one that you did check off and somehow it didn't keep that setting. That seems like it happened to me, unless I just was making a mistake. I don't know if this is correct, but it seems that any bones that become dependent on orientation constraints after you've frozen them, if you try to freeze them again after you've made them dependent on an orientation constraint, like a controller like this, it doesn't work right when you try to refreeze everything. Basically, my recommendation is to make sure you have your entire skeleton selected before you ever go ahead and start adding shapes, controllers, and constraints, which we actually did before, so we did do that, and then freeze transformations. And then when you're adding controllers, make sure everything's kind of linked up together, and then you can grab all of those controllers, just the controllers, not the bones, and freeze those constraints, or freeze those transforms with the alt right click. And then that way you can just go into shape mode, select only the shapes, select all of them, and if you want to reset the character completely, you can alt right click and go transform to 0. In this case it looks like some of these have never been frozen, so make sure to grab all of them and freeze those transforms. And so now if I change some things, should be able to alt right click Should be able to grab all those shapes with shape mode only and go transform to 0. It says one or more was not frozen, which is weird because I thought I selected all the shapes. Let's freeze the transform. Okay, so if I select this one, this one, this one, and say this one. Apparently I don't have this one wired for the tail. Oh, because of the freeze transforms, that's why. You lose your wiring parameters when you do that. I'll just have to make sure to rewire it. Okay, so I'll select all of these. Transform to 0. Just got to remember, if you're going to change the wire parameters, or if you did something wrong with the order of freezing transforms or anything like that, what you need to do is unlink your controller using unlink, then select and link it to the parent controller. Then you can alt right click and use freeze transform, and then you can, as long as your pivot and object is aligned orientation wise to what you want to control, you should be able to wire the parameters together for the z-axis, for example. In this case I want it to half the amount, so the offset change will be half the amount if this changes. I'm not going to do that for all the parameters here. And just to make sure it works, do a quick test. We can do the same thing for the next bone, refresh in the right side here. And in this case, instead of 0.5, I'm just going to connect them directly. So z to z, y to y, and x to x. Grab the third tail bone, refresh the right side, and do the same thing, except this one's going to be 1.5. So times 1.5. And save it. Just testing out some of these controls. Spline is rigid when the hip moves, which is probably not a desirable behavior. So we could add a wire parameter from the hip controller to spine 1 and spine 2. Spine 2 being less affected. I'm going to click on spine 1 and go to the animation or the motion, and I'm going to go to the rotation menus, and there's a track list here for the rotations right here under assign controller. Where it says available, I'm going to add another one. So we can't use this 0 Euler XYZ anymore because the orientation constraint is affecting it. So let's go down here and click on this assign controller, create another Euler XYZ, click OK. So let's have to keep in mind that we're not using the 0 Euler, we're using this new Euler. So grab the hip here, right click, wire parameters, transform, rotation, and so when we rotate it on the x-axis, go to click on spine, transform, rotation. I want to go to this new Euler XYZ and rotate the x-axis, and we'll connect them. If you start with the spine and go to the hip, then you'll have to connect the other way. I started with the hip, so I'm going to go to the right, connect, and then I'm just going to grab this and see what happens. Looks like it's going the wrong way. So let's flip this with a negative and update. And we'll divide this by 2 because we don't want it to move as much as Elvis when it turns. Okay, that seems to be fine. And we'll do the same thing. Wire parameters, transform rotation, X to spine 2, which will rotate. Oh, we got this available slot here. We got to add. So grab this and add to spine 2 a rotation controller in available. So click on here, assign controller, Euler XYZ. And so now we can grab this hip controller and wire up its X rotation to spine 2's rotation of the new Euler XYZ X rotation. And if you remember, it's a negative, and this time we want to divide it by more. You could divide it by 4. I'm going to go with about 3.6 maybe, so somewhere between 3 and 4. Connect. I'll just watch it when I rotate it to see if it looks like it's following at the right amount. That looks good. So it's divided down to a very small percentage here. This one I wouldn't even worry about it. Virtually nothing would be visible and change, because by this time it would be like divided by 7 or 8 or something. Before we begin the arms, double click on each set of arms at the base bone of the arm to select the entire chain of arm bones. Use Alt right click and transform to 0. Make sure that they haven't been rotated out of position. Also check visually to make sure they're identical and totally symmetrical. If they are not, it could run into some problems with synchronizing the animation on each side for certain types of animation cycles, if you want the animation to be symmetrical. I would actually suggest doing what I'm about to do with the legs too next time you do legs, although I usually have more problems with the arms when I do this. The first thing I'm going to do is I'm going to take this template piece shift drag it right, and I'm going to say I want 2 copies. This first one I'm going to grab and drag to the right side, and the other one to the left side. I'm going to place them up above and behind the shoulder. If we go to the left side, you can see that these are way back here. Let's drag them both up so that they're about here and they're easy to grab. What I'm going to do is I'm going to align each one individually to its corresponding bone. In this case, the first one will be the right bicep by axis and orientation, and I'm going to do the same with the other one with the left bicep, axis and orientation. I'll color this one green and this one sort of a blue, kind of a purple. These are editable splines. I'm going to go into sub-spline mode so that the pivot stays where I want it to be and where I need it to be. But what I'm going to do is go into left view and use my snap settings. I'm going to drag around all of the sub-spline and drag it back so it snaps to the grid. I'm going to go to the right view, hit P, so drag around all of the subspline of this one. First, actually, let's rename this other one so we don't get them confused. This will be controller right shoulder, and exit subspline. Click on the other one, controller left shoulder, and click on subspline R and drag it out so that it sort of snaps to the grid at a similar location. It's going to zoom in and kind of fine tune this position so that they kind of line up. As long as the pivot, axis, and orientation matches the joint, it's not going to matter. And I can exit the subspline now. Actually, I could grab this one, grab all of it, turn on all the snaps, scale it up by 3, 4, 5, 6. Exit subspline and do the same with the other one. Got to be in subspline 6. Exit left, make sure they line up good. Shift R for right view because that's my hotkeys. We'll make ones for the clavicles. I'm going to grab this guy here again, template. I'm going to shift drag it to the right or to the left, 2 copies. And this one I'm going to align to the left clavicle in position and orientation. And I'm going to call it CTRL left clav. That one's going to be this color. I'm going to grab this one, CTRL right clav. It's going to be green, and I will align it to this one, axis and orientation. I don't want to change the size of them, but I'm going to go to the sub-spline mode, left view. And what I'm going to do with this, select all of it, move it up and to the left. Then I can unselect that, select the other one, sub-spline, select all of it, move it up and to the left so that they essentially overlap. I'm doing all the controllers first to avoid complications later. I'm going to grab this again, shift drag to the right, 2 copies, and this time I'm going to use the wrist pivots, or the wrist nubs, which will control the hands. So the first one, CTRL, I'll call it left hand, and we'll make it that purple-blue color, and align it to the nub left wrist. Position and orientation. Same thing with the other one, CTRL right hand, aligning it to the right nub. Let's change the name of that nub. I need the 2 on there. And we'll make the color green. I'm going to go into sub-spline mode here, select all of it, and I think I'll just move this one to the left and upward. Deselect the sub-spline, select the other one, grab the wrist there from the looks of it, so controller for the hand, left, or I could go to right view, go to sub-spline mode, select all of it, move it up to the right so that it kind of matches the other one. The reason I want these to sort of match up with the ones on the other side is to make it easier to do symmetrical animations. Exit sub-spline, let's go to top view, and we'll go into create shapes. Could use an arc or a circle so we can grab it from both sides. Make it into an ellipse, so maybe I'll do an ellipse. Drag it out, enable and viewport, see how big this looks. So what I'll do is align this with wrist 1, so it'll be around where the bicep is. Before I do that though, let's shift drag this to the right, and we'll call this CTRL left bicep. Use the color of it. We'll make sure this one's called CTRL right bicep. So this one I'm going to align to this first wrist bone. Position and orientation. From the looks of it, we want to change a couple of its parameters, and this is before we've changed it to a spline, so we don't have to worry about modifying these parameters, so we're not really scaling it. Okay, and it should be easy enough to grab from both sides now through the arm. So I'm just going to copy this parameter, and it's 5.569 for the other parameters. So let's go to here and paste this parameter, and then we'll align this one with this wrist, axis and orientation. Before freezing transforms, we want to make sure we've linked everything. This one will be controlled in position and orientation in space by the pivot center of this one, and this by the pivot center of this one. So the parent controls the child through the orientation and position of the pivots. Since geometry was transformed in sub-spline mode, the pivots should still be where we aligned them. So the pivot for this one is going to be here, this one's here, as though they hadn't been moved from where they were around that bone. That's why we use sub-spline mode. If you moved or scaled the object itself, you're going to throw things out and it's not going to work right. So let's grab this one. We'll say the parent is going to be this one. We'll grab this one, its parent is going to be this one. And this one is going to be parented to the clavicle. The clavicle is already parented to spine 3. We can grab this left controller here and parent it to spine 3 also. We'll do a quick test, make sure everything works the way we expect. Okay, so those are all parented properly. We'll do the same thing on the other side. This one, parent is going to be this one. This one's parent is going to be this one. This one's parent is going to be the clavicle. And this clavicle controller's parent is going to be the spine 3. So now what I would do is hold down Control. Make sure you don't miss any. Since these are all parented, it's safe for us to do a freeze transform on them. Alt right click, freeze transform. The first thing I guess we could do is make it so that the clavicle is oriented by the clavicle controller. So selecting the clavicle bone, we'll go animation constraint, orientation constraint, and make sure that for every time you do one of these, you go into the rotation menu on the right side and click on keep initial offset. We could end up corrupting the model for other things that might want to do with skin or clothing or anything like that. So we want to make sure that keep initial offset is always checked. So doing the same thing on the other side, orientation constraint, keep initial offset. So now if I rotate this, it should affect the clavicle. Okay, moving on to the shoulder. When you animate it, you'll have to animate these separately and make sure that the clavicle moves a little bit when the shoulder moves. So maybe 50% of what the shoulder is doing sometimes when it goes up and down. So let's grab this first bicep bone, which is technically the shoulder right here, and give it an animation orientation constraint to this controller here and make sure to check keep initial offset. We'll grab this bicep on this side, technically the shoulder, and use an animation constraint, orientation, and shoulder, and make sure to check off keep initial offset. And I think we forgot to rename some of these. Like this one should be CTRL L shoulder. We'll move on to the controller for the left bicep. I'm going to go orientation constraint and click on wrist 1 with keep initial offset checked. And I'm going to go into hierarchy link info, tell it that it can only rotate around the Z or upward axis. So I'll lock X and Y out. While I'm at it, I'm going to make it so that X, Y, and Z for each one can't move either. If we've made a copy of these over to the other side, if you're choosing to do it that way, you might have some problems with these locked, so you might not want to do that if you're planning on doing something like that. Make sure you do not uncheck the inherit, because we do want to inherit. Let's go over to this side and grab the wrist and say orientation constraint to this one, and keep initial offset, and I'm going to lock this one's position and allow rotations only around Z. When the shoulder rolls, this will be able to change the direction in which the bicep is curling. Oops, I think I turned off my keep initial offset there. Let's grab this one, seems to be working. And we can put those locks on these other ones too while we're at it. Don't really want them to move or scale. This prevents accidental scaling and movement of these, where we just want to be able to control the rotation of the joint for those. So for this controller here, let's grab the wrist nub. With wrist nub selected, use animation constraint, orientation, and choose the right hand controller. Make sure again to keep the initial offset. And again, we'll restrict it from being moved or scaled. Selecting the nub left wrist, animation, orientation constraint, controller right hand, keep initial offset, restrict motion and scaling. Now we'll save. Now you'll notice if I rotate this one, this middle bone doesn't really follow. You could either use wire parameters to make it rotate at half the amount that this one does. Another thing we could do is use an animation constraint between this one and this one so that it rotates at 50%. So what I'm going to do is select the right hand controller and go wire parameters, transform, rotation, and we want to rotate on the x-axis for right wrist 2. Connect them and divide it by 2. When I rotate this, it should rotate about 50%. Let's go over to the other side and do something similar. Click on this, wire parameters, transform rotation, X rotation, and we want to affect left wrist 2. Rotation, X rotation. Connect them and divide by 2, update. Should be a half speed rotation, and it works effectively. Save it. Oh, from the looks of it, we made a mistake here. We've got this one orientation constrained to the wrist rather than the other way around. So let's grab this constraint here and delete this orientation constraint from there because that doesn't belong there. And rather grab the wrist one bone on this side and constrain it to this. This is why it's a good idea to test things as you go. And this one should be orientation constrained to this, which it is. And likewise, if I turn this one, I should change the clavicle orientation. And I'm just going to test out my freeze transforms. So I'll grab that one, and that one. Transform to 0. Same with these. Let's make sure everything's good. I'll grab all these and transform to 0. Look in the front view, make sure everything looks balanced and correct. Also check the left view and make sure everything looks lined up, which it does. And next I'm going to move on to finger controls. I could create little individual finger controls. I think what I'd rather do is create an attribute holder that controls finger curl, finger spread, as well as thumb curl and thumb spread. And I should be able to curl each finger individually within that controller as well. So I'm just going to grab this controller and I'm going to go to the modify panel and I'm going to add an attribute holder. The attribute holder for the hand will control fingers. So let's go to the parameter editor. Suppose we could start with the thumb. So I'll say left thumb curl. We already know we're in the left hand, so let's just call it thumb curl. 0 to 100 gives a fair amount of precision. I don't think we'll need a whole lot of precision though, really. I'll use the right align option. We'll add that to the attribute holder. So curl would bend the bones, I would say in this direction, wouldn't it? Kind of inward to the palm. And there'd probably be a spread parameter as well, just for the thumb to kind of widen between the fingers. And so sort of this gap right here, and the other one kind of curls everything in. So let's go with thumb spread. We'll add that one as well. We could put a spacer in here or have two different titles here, but I'm just going to continue with these. I'll say index, curl, and add. Mid, curl, add, ring, curl, and pinky curl. Also, we want the fingers to be able to spread apart, so I'll add a finger spread and add that one. And that doesn't quite fit in there. Let's edit that. I'll just call it finger spread. Well, we can read it, so that's good enough. Okay, so for thumb curl, we'll have to use the... Well, we could actually use wire parameters for this too, instead of reaction manager. So for this to curl, I want this to kind of bend in a way that looks natural for the thumb bending. And let's grab this, and I'll just use wire parameters, I think. Let's see, what axes are we dealing with here? Z, Y, and X from the look of it. There won't be a lot of X rotation, I think, just mostly Z and Y. Okay, wire parameters. Start with Z, modified object, and we're going with thumb curl right now. And I did this kind of in the backwards order, so for this one I'll have to say that direction, connect, and let's see what happens as I adjust that parameter right now. So we want it to go the other way. Let's say negative, update. Okay, we're going to have to reduce it quite a bit because when it reaches 10 it's going to be far too big. So maybe try 0.1. 0.1 takes it about that far when it reaches 10. Maybe 0.15 to give it a little more, 15%. 0.12. Now we want it to rotate around the y-axis a bit too, so let's go with that and connect right to left. Start with 0.1, see what that looks like. I can hit F4 so I kind of can see what the geometry is doing a bit better. Not bad. Well, I think these percentages are a bit high because we want this to bend also. That part actually bends that far. Let's go 0.08. I'm going to go negative 0.02 for the X rotation here. And we'll grab this next one here. Refresh on this side. Grab the Z first. It's going to be a leftward connection again. Negative and 0.1. Out. I'm just comparing it different values when I do it. So here if I times it by 0.1, update, rotates down that way quite a bit. I would say too much, 0.4 maybe, but let's also rotate in the y-axis, times 0.05, and looks like we might want to rotate the x a little bit on this one too. Now let's see what it looks like if we do 0. So yeah, I would say maybe 0.03. Should that be negative? That should be positive. It's a bit strange that for this one, we used a negative on that. Might not want any X rotation on that. I'm going to go 0.01 to get that angle. And then this one, bend a bit. Let's refresh that one. Start off by left connect to the Z rotation. And I'm going to say times 0.01. 0.03, and it's in the negative direction. Or is it 0.3? Okay, try 5 and hit update. It's a bit better. I'll do this y left times 0.04 maybe. Maybe make this one a bit more. And then we'll give it some x rotation times 0.02 and leftward connect. Let's say 3. Alright, so let's grab this hand, bring the thumb curl down. It's going to delete these keys that I made here. Let's turn off auto key. Okay, maybe I will turn on auto key and bring the thumb spread up to 10 here. We could even set thumb spreads that have a negative value also, like -5 or something. But go to parameter editor, click on edit, and we'll change thumb spread as well as finger spreads that they're allowed to have some negative value. So I'm going to say maybe -5. And finger spread, the negative value will close them together, so I'm going to say -5 also. We can adjust those later if we need to. Okay, so thumb spread, we just want it to rotate around the z-axis mostly, because we want this to get closer and spread apart. I'm going to grab this one, I'll do it the other way this time. Wire parameters, attribute holder, custom attributes, thumb spread. We'll start with affecting the rotation of this around the z rotation. Because if I go to local, or is that the y rotation? I suppose that's actually the y rotation. So let's grab the y rotation on this side and the thumb spread on this side, mapping to the right and connect. I'm going to say negative times 0.1. Okay, so actually this should be positive. Let's go to frame 20 here, grab this guy. First we'll set auto key, bring it down to -5. So there's neutral and there's all the way back. And actually that looks pretty good. Now what happens if we got this and this? Yeah, it looks pretty good. So I can curl that in, change the thumb spread like that. I'm forgetting that I got auto key on here. Let's turn that off. So it doesn't give us complete control over these bones. If we require extraordinary control of the thumb bones, we could actually just take the wiring off of the thumb bones and put a little thumb controller on here, allow us to manipulate these bones individually in a very specific way, X, Y, and Z rotations. But I think it really would just be just as easy for an animator to just make the character semi-transparent, click on bone only, and just go ahead and animate each one of these individually. In fact, I think we're going to do that with the hair instead of bothering with a bunch of controllers for the hair. Professional rig though, you probably have something set up outside of the head that allow you to control the bouncing of the hair. You might even want to use a spring system to control the bones of the hair so that they bounce around fairly realistically. You could even mark those bones as spring bones, just using the text, and then have your game, when it sees that text, when it's loading, it's going to flag that bone in its property as a spring bone, and it may add it to a spring bone list rather than the regular bone list. And so then those bones would actually be controlled by your spring bones, and that would animate the skin mesh that way, but that would be a more complicated setup than what I'm going for here. Okay, so let's see. Next, let's make it so that we can control the index curl. If we wanted to always have the fingers curl the same amount, which I don't really want to do because I want to be able to do like peace signs and finger gestures or whatever. So that's why I'm doing them as individual, but you could have like an individual finger curl set here. You might think, oh, I could have a finger curl parameter and then feed it into each one of these individually, or make it so that it adds into these ones. I'm actually not sure how you would do that, because if these ones are changed when you modify the finger curl, it's not going to work right. So let's go with index curl first. I'm going to grab the first index, refresh, grab the index curl over here, refresh, and the local is the Z that we want to rotate around. That's from index curl. So mapping left to right, connect. So this should be negative. I'm going to say times 0.1, update. Okay, and then I'm going to grab the next bone, refresh in here. I'm going to times 0.1 for that one too. Oh yeah, it has to be negative. Update, grab the next bone, refresh in here, transform rotation 0 Euler, Z, negative index curl, times 0.1, connect. So the fingers curl in, but they don't quite form a fist. So let's increase this to something like 1.3 or 1.4, update, refresh this slide, 1.4, update. Refresh, 1.4 update. Okay, 1.4 worked pretty good for the index, and we can take that to 0. We could use it as a reference, but I'll just put it 0. Let's go to 10 with the mid curl, grab the first mid bone, refresh, Z rotation. We want mid curl on this side selected, and it's going to be negative times 0.14. Connect. And then the next one, refresh, negative times 0.14. Map right, connect. And then this one, I'm just going to copy this, and then I'm going to hit refresh, so that's at mid 3, and paste it in here. Okay, and then I'm going to bring this back to 0, and do the same for the ring curl and the pinky curl. Make sure you have ring curl selected on the left side, and then ring 1 selected on the right side. Say negative. So far, times 0.14 has worked for every finger. You might need to change it up a bit for certain fingers, depending on how long they are and what angle they are initially, so they might not be exact. I should mention, when you go to do the attribute holder for the other hand, what you can do is you can actually just grab the modifier that you added to your left hand, drag it and drop it onto the right hand, and it'll have the same parameters in your rollout. Okay, so now I can click on this pinky here, and pinky curl on the left side, refresh on the right, and you should see the 0 Euler under a frozen. So I want to click the 0, Z, and I'm just going to keep going with this times negative 0.14 and make sure this is working. I'm just going to put the pinky curl at maximum, and I'll just continue down the chain here by refreshing. Hit pinky 2, transform rotation, 0 Euler, Z, paste, connect, and then again. 0.14 might be a bit extreme for the pinky. It looks like it's going right up into the hand, so we could tweak these at the end, but I'll allow it. Let's grab onto this one, take this down. Just going to save this quick. Now for finger spread, let's grab it on this side, and I'm not going to control the thumb spread because that has its own. Let's just do these. So I'll start with index 1 maybe, and I want to rotate around the y-axis. Say times 0.04 to start with, just to see what that does. And first of all, let's make sure we set the finger spread at maximum amount. And it looks like we still had the left pinky selected, left pinky tip selected when we did that. We didn't refresh. So let's just clear this, disconnect these. Let's make sure we are working with the right parameters this time. So where parameters, transform, or no wait, modified attribute, finger spread. Starting with this index, rotation in the y, times 0.01, just to start with. I'll connect those, and let's boost up this. Okay, so we want to go in the negative direction, so times negative 0.005 maybe? It's a bit too much. 3, that looks about right. And let's go to the other extreme, which is 5. So what we can do here, we want to change our default. We can add in a starting value here, but in this case, it doesn't look like we need to. We could even change this to 3.3, 3.8, maybe more, maybe 4, 0.04. Let's see what it looks like all the way the other way. Okay, that's fine. Like I said, you could add an offset in here, or subtract a certain offset to have a different starting angle when it's at the negative value, and as well as when it's at the 0 value. Let's click on this one, refresh. Okay, I'm not going to have the middle one move at all, actually. I'm going to refresh for ring finger over here, ring finger 1, and go to rotation on the y-axis, times this by 0.04. So what do we got this set to? This one might be very much the same for 8. Let's bring it down to 4. We don't want it to spread too much. Actually, it should spread about the same as the other finger. If we're to be realistic, if you spread your fingers apart, you can see they spread about the same. So I'm going to grab pinky 1, refresh, and I'm going to say times negative 0. Or just times 0.5. See what that does. 0.5, not 5. Okay. At the minimum value, the fingers should be together. Ooh, times negative 0.05. I think so. No, because that's backwards. I'm going to say 4. That's about the range change that you should expect. Now here's where we'd add an offset. Minus 0.04 or minus 0.1. See what that does. 5. Might be a bit too much. 0.45 or 7. That's about right. I actually could put this at 0.5. That's probably closer to what it should be. Now if I spread it, now what I would say is this one and this one should be a little less, and that one should be more. So I'm going to say times 4, 9 maybe, and then I'm going to refresh this, go to y, change it to 0.4, date, maybe even 0.36, 0.036 I should say, maybe 0.032, no, 3, maybe less, maybe 0.028, maybe this one a bit more. I'll just have to fix the offset for that. This one, we'll refresh to here, maybe go 2.8 with that one. Okay, now I'll try sliding this up and down. It's maximum open. This one can maybe go a little more. 0.064. Now, grab this and close the fingers. May need to make some adjustments. These ones need offsets now. Let's refresh this one, grab the Y. We get 0.1, we'll try that first. That looks about right actually. 1.3 looks even better. Grab this one, refresh Y, plus 0.13, see what that looks like. Looks good actually, so it might be 0.1.2. For each joint, write down the formula you used, and then do the same sort of wiring situation on the other side. However, you might need to change some of these minuses to pluses and pluses to minuses, because you're rotating in the other directions. Found some wire parameter settings I liked a bit better. I wrote them down and I'm going to copy them over to the other side here, starting with the thumb curl, which is the most complicated of them all. Okay, so I'm going to boost up the thumb curl value here just to make sure this is working right, times 0.03 for the X value for thumb 1. And I don't have a Y value first, but I have a Z value, and I'm going to go negative thumb curl times 0.1, connect. Now, since this is the other side, we want to go in the other direction, so update. Let's see what happens if I do negative for the X. Okay, so that's actually probably what I want. So moving on to the second bone, I'm going to refresh, and I've written down that it's the same for X, so what I'm going to do, because I found it's actually negative, I'm going to say negative times 0.03. Let's see if that looks right. Looks about right. And for the Y value, times 0.065, and for the Z value, the Y value seems to be the one that's not changing, so this will be, I have negative, so this will be positive, so I'm going to put 0.07, and that looks right. I'll refresh the next one on this side. X value should be negative instead. So I'm going to say negative 0.02. Y rotation should just be the same, except it's going to be times 0.06. And the Z rotation is going to be positive instead of negative, and it's going to be times 0.06 also. And it looks to be correct. It looks to be about the same as what I had. And again, I could tweak these later if I'm not happy with them. Grab this, go back, and we'll go to thumb spread and boost it up. Grabbing thumb spread on this side, and then thumb 1 on this side. Thumb 1's the only one affected for Y spread. It's going to be around the Y axis times 0.1. Connect. It seems to be what we wanted. I'll set that back to 0. And I'm just going to boost these all up so I can see that it makes a fist when I'm done. In the meantime, I'm going to save this. So I'm just going to start with this index curl and then refresh for this side to get the index 1. We want to rotate around the Z. It was negative 0.14, so I'm going to try 0.14 on this side, because I believe it rotates the other direction, and it worked. So I'm going to copy this value. It's going to do the refresh thing, go into each Z for these, paste it in, and connect it. Don't forget to make sure that you're selecting the correct one on the left side each time you move to a new finger. Okay, and then back to finger spread. I got finger spread selected here, Y rotation selected for index 1, and I have wrote down times 0.028 plus 0.12. Well, let's see what that does on this side. From the looks of it, the offset is actually inverted on this side. Or maybe not. Maybe plus is actually correct here. Fingers seem awfully close together though. Let's refresh this one. Go down to finger spread. Grab index. Fresh. Negative 0.028 plus 0.12. Okay. I think I know what's going on here. Let's refresh this one. And refresh this one. Grab spread. Grab Y. Okay, did I have the wrong controller selected too? Oh, I've got thumb spread selected on this side. I've got to get finger spread. There we go. So this should be negative. Let's test this out. There, that looks a lot more like what we expect. I can go to this one, refresh it, in here, click on Y, and this one's going to be 0.028 minus 0.13. So this one will be positive because it's going in the other direction. And then we can grab the pinky one, refresh in here, grab Y, times 0.064 minus 0.5. Let's test this out. There's a spread. Looks good. At this point, we've done a lot of complex things we don't want to lose, so we're going to save it. And next, we'll move on to breaking up the head and the eye controller and facial animations, which will probably be a lot more fun.